105, and then it will go to the IT forensic class and then enroll. The enrollment key is ITTS. I forgot. Yeah, let me check. Let me check the enrollment key. Where is the enrollment key? Here, participant, enrollment method, self enroll. Okay, here. ITTS PU 2023. All capital letters. ITTS PU 2023. Okay. So that's the enrollment key. Okay. In this particular class, let me go back again. Okay. Oops. Again. One more. Okay. Okay. I will skip the how many? One, two, three, four, five. The first five module. I am assuming that this particular module has been delivered by Ibu. So I will start with my forensic class will aim mostly to network forensic. A little bit on file system, only one. Maybe two. uh, okay, I will give. So the first five I will skip, but the module is still there. You can access the actual module is in wiki. I will post the URL. Okay, this is the URL. Okay, it's in onocenter.or.id/wiki/ it's forensic IT. This one URL. Okay, so you can search. The material is here. Okay, it has two language. This part is Indonesian. The second part is English, Indonesian, English, and so on. Okay, all the questions are in English. So, so I think all of you will be surprised in English. Because if I use Indonesian, some of you will having difficulty to read the questions. Have to use the Google Translate and so on. Okay, now, so I will skip this part, the introduction, how to what's it, acquisition the data, how to analyze the data, but the material still there. You can read how to investigate operating system, investigate network, and then I will start discussing the class starting on the email forensic, SQL injection, command injection attack. All of these are network attack and backdoor command injection attack. And then this one is not network attack. This one is forensic again, but this one is for Linux operating system. And then this one is for mobile, Android, forensic handphone. How can we analyze Android, including how to access the file system and so on. Okay, and then this is miscellaneous network attack, MySQL brute force, SSH, enum brute force, and so on. So this is again attack, but network attack. The last one, how to report on our forensic research. Okay, this one is the most important thing. I think I have to move this one. I have to discuss this one first before we discuss the rest, actually. Okay, so I will skip the rest uh, uh, because I have like what, like eight modules. I have seven scheduled meeting, so we have seven meetings, but I have eight scheduled. So I will start with this one first because this is the most important one. Oh yeah, by the way, uh, please do the quiz. Originally, I was thinking to have a project for this class, but then if it is project, it will make a lot of burden, uh, trouble for all of you. So I changed into quiz. So do the quiz. It has like 100 questions, random questions. Currently, I have only about 200 questions in my question bank. So I think you will be survive to do the quiz now rather than later, because I will increase the number of questions by uh, by week. So every day I spend like 20 questions for three questions to the quiz. So my suggestion is do the quiz as soon as possible because the number of question is still very low. Okay, now back to here. So I will discuss the how to do the report first. Knowing how to do the report, then it's easier, I think, it's easier for you to understand why we do these things. The problem is to understand. So the way I will discuss things is something like this. Let me see. Okay, this one is to give some idea how my class will be conducted. I will do something like this. So our class is in this one, forensic. Okay, the class is on forensic. Unfortunately, if I discuss only the forensic without discussing how to attack, it's difficult. So to understand how to do the forensic, we need to understand how to attack the system. And then knowing how to attack, then we can do the forensic. And then from the forensic, we can mitigate. We can discuss, we can uh, well, not reduce. Well, we can make some scenario or some proposal how to mitigate the attack. Okay, so this becoming a single. So the my module will be something like that. Most of them. So how to do the attack, how to do the forensic, and how to mitigate. The problem with the attack is we need to understand the system that will be attacked. The system will be Linux. So I know most of you are not familiar in Linux. So this will be tough. This one is tough. I live in Linux, uh, like almost my entire life. So for me, it's easy. But many of you, because many of you are familiar with Windows, so this part will be difficult. If you know Linux, the rest is easy. Okay, okay. So that's the biggest problem actually, knowing the system, because most of the server we are running on Linux currently. So it's much easier to. Uh, so this one is more the hands-on and so on is based on the actual system on the ground. Okay, so I will start with the report first. The outline is actually simple. This one normal. Let me make it bigger. So we need title, name, position, affiliation, date. That's it. That's as simple as that. Table of content, normal. This one is the most difficult ones. Okay, this should be something like one pager executive summary. It has it must describe the key findings of our forensic activities, conclusion, recommendation. It must be very concise. It must use. We have to reduce all the technical terms. So the language used in the executive summary is is non-technical language, because this part is the most important part, because this will be read by the judge, will be read by the one who gave money to do the forensic and so on. So this part is the most difficult part. Okay, this must be one page max if possible. So this must be one page, and then we inside, we need to describe the introduction. We need to describe the background of the case, brief description of the case under investigation, objective of the forensic investigation, scope of work, device and system that we examine, the data we analyze, the methodology. Okay, so this will be described in this course. So this part partly will be discussed in this course. The tool and software will be I will use as much as possible open source software. I think I will use all of them. I will mention some what proprietary software, but it's mm, I'm not that keen on proprietary software because we have to pay. But if you have money, sure, you are welcome to use any tools and software you like, especially for mobile forensic. It's quite expensive. We need not only software, we need hardware as well. So for mobile, it's more difficult. The guy in Indonesia that active in mobile forensic is Joshua Sinambela. This guy. This is the person. So Joshua is very active in mobile forensic, and I think he has several tools for those things. One tool is cost like 100 million rupiah, so it's quite expensive. He has several of them. He is quite keen and serious in mobile. So this one is a workshop on multimedia forensic fundamental. So he's do a lot of forensic stuff. Okay, this is his location is in Yogyakarta. Okay, now back to here, but I will use open source software. Unfortunately, most of the software can only be used over Linux. I think many of them. Uh, okay, now this is the introduction. The procedure to do the examination. Basically, we have to uh, first we have to collect the evidence. Okay, accept the evidence from the ground. We need to do documentation, photo picture, take picture, and so on, and then make sure all the evidence is stored properly. Okay, and the problem is this evidence mostly soft copy. Now, in soft copy, it's more difficult to do what? It's not physical. It's soft copy. It's not physical. So we have to make a lot of precaution to make sure no one will tamper with the evidence. Okay. Sometimes we have to do several backups, for example, and we have to encrypt the evidence and so on if you need. But encrypt is actually changing the evidence, so it's, it's a little bit not a favorite method, but well, sometimes we need to do those things. Okay, so that's how to take some process to accept the evidence. Okay. Oh yeah, we need to take note time and date, condition of the evidence upon receipt. Normally, we need to make a copy of the evidence. So we need to make sure the original evidence is. We will not do any tampering to the initial evidence. Only the copy will be tampered. Okay. No, having the copy, then we can do the acquisition process. This is done on the copy of the evidence, not the original evidence. The original is safe. Okay, so then we do some acquisition process. We need to master some several data acquisition method, and then we need to verify integrity of the data and so on. Then we need to analyze. Okay, there are many type of analysis, file system, network, malware, and so on. And then of course we need tool and technique to do this analysis. The problem is make sure all step is documented in detail. Okay, this part is tough. Okay, because actually many of my students is not that keen enough to do document to do the documentation. So this is difficult part. Do documentation. Many people would like to play around with the data analysis and so on, but they are forget about documenting what they are doing, and that's becoming a problem when you have to write the report. So this is important. Not many people keen enough to do the documentation, and then after do the analysis, then we have to present the results. Okay. Uh, some of the findings, for example, we need to identify the suspicious file or significant file, what kind of usual activity, evidence of data manipulation, digital footprint, and so on. And then we need also to do some data visualization if necessary to clarify the finding. Okay, and then we have to do some more deep analysis, interpretation of the factual findings, and relation between findings. So we may likely to have several findings or many findings because this is network. Uh, we may likely to find many findings. For example, we may find fail login attempt, and then we may file. So the way the hacker works, they normally to do some they will try to penetrate the network, and when they try things like that, they will try it many times. So we need to find the log on how they do the attack and so on. Okay, and then the attack, how they manage to, well, not enter, they manage to breach the operating system. They may likely to change the log and so on, and we need to draw relationship between findings for this particular case. Uh, After that, we can make some conclusion. Okay, but make sure we are not putting any opinion. We only presenting the fact, not opinion. So no opinion, fact only, and honest. Okay. Uh, it's very similar to research. To do the your work in research. Okay, when you do your paper journal and so on, it's actually very similar. But this one is to find things to be presented in the court for the judge and so on. Okay, but after we do some conclusion, we may likely to suggest some recommendation. Okay, for example, to improving system security and so on. So this part, in this recommendation part, our knowledge on mitigation becoming important. Okay, on this part, especially on this part, sorry, this okay, this part and acquisition process and so on. Our knowledge on the system, operating system, the network, and so on becoming important. We need to understand which file we need to to see, check, and so on. Okay, because this will likely we need to check file, we need to check log file. Sometimes we have to do some hex dump, we have to disassembly some malware and so on. So this is not that easy. Okay, uh, our ability, not ability. If you are not familiar with the system, you you will. we will having difficulty to understand which one is normal, which one is not normal. Okay, so in doing some forensic, we need to we have to be familiar with the system. Okay, it's not like if we are not familiar, so we because this is very much human. This the decision to see things, which one is normal at normal, is decided by human, not by tools or software or application. So application tools and so on will only grab the data for us. We as human, that the one who will decide whether this one is normal or not normal. Okay, so at the moment human, but as data is being collected, a lot of data being collected, now more and more AI, machine learning, goes to this kind of activity. So the normal thing is becoming training data. The not normal thing also can be a training data for AI or machine learning. So both can be that. But still, it's still in very early stage, so it's better to have the actual human knowledge for these things. Okay. Okay, so that's the okay. We need some reference if any. Okay, we need to make sure when we write the report, it must be detailed and accurate, clear language, easy understandable. Avoid technical jargon unless absolutely necessary. Objective, free from bias, confidentiality, because we are dealing with very sensitive information during investigation, so we have to make sure we need to maintain confidentiality. Okay. Additional tips: logical structure, easy to follow structure, data visualization will be helpful, graph, diagram, table to present complex data. Cross check on all findings. So make sure all findings will be logical and related to one another. It will be helpful also if we can ask other person to review our report before presentation. So this is the actual. So our class will be focus on this one methodology and some of this, not this, not this one, acquisition process, data analysis, documentation. I'm assuming because all of you is master degree program, so I'm assuming writing things is part of your life. So this is for I will skip this one. Okay, so that's about the outline of the report. Uh, let's go for the examination procedures. This is more detail when we do some digital forensic examination procedures. Uh, when we receive the evidence, okay, make sure, okay, this can be the most easiest things. This is done by database or Excel, but there is application to do this thing as well. Okay. Of course, we need to take note date time of when we receive the evidence, the condition of the evidence. Okay, whether it is crack, damage, sign of tampering, it power states on or off. Okay, uh, initial steps taken. We need to do the documentation, make of the detail of the device, brand, model, serial number, all necessary information must be all documented, very very detailed. So this part is we need to have some passion to, to take all the detail of the evidence, take photograph from several angle before and after examination. Uh, This is useful so for documentation. This is the initial condition. If there is any changes during the examination, this is if the evidence is hardware physical. If it is software, it's not photograph maybe, but we take note on like the size, the what size, date. So if we have file, okay, let me show you a file. So we have information who owned the file, when was the file created, what time, and the size of the file. So this is the owner, group of the owner, the permission of the file, size of the file, uh, date, time, the file name, and so on. So we need to take note of this. This is like if it is software, not a file evidence. So we need to take note of these things. Okay. Of course, we need to, if it is physical, we need to make a short video, unpacking the device, and make sure the video also will be the, if it is in URL, we need to uh, record the URL of the video in the evidence receipt. Okay. Now, the acquisition process, we need to take note several things. We have live acquisition, we have static acquisition, we have this imaging. Okay. This is to grab the data, take the data. Live acquisition is copying data directly from a device that is currently operational. It's on. In live acquisition, for example, if we want to analyze a smartphone, Android, the smartphone is operational, is in on condition. Uh, this method is useful for capturing volatile data, data that very easy to lose, such as data in memory. For example, ransomware. Ransomware is normally run in memory. It's volatile, and when the power off, the data will be lost. So we need to use the live acquisition model to capture this kind of data. Okay. Static acquisition is copying the data from a device when it's power off. Okay. This method is more commonly used. So this one is more commonly used than the live acquisition. Live acquisition is more difficult. Static is more much more easier because it doesn't disturb the device condition. This imaging is copying the entire storage medium, the entire storage, not of course we can always copying part of the storage like one of the partition, but normally we creating bit by bit copy of the entire storage. This is the most recommended method to maintain data integrity. Okay, so this imaging. Uh, Many of us actually, when we get some hard disk as evidence, we will likely creating bit by bit copy of the entire storage medium. In Windows, I think we can use Ghost or something. In Linux, we can use DD. Okay. Of course, we need to have some uh, integrity verification. We need to calculate the hash value, both original data and its copy, compared to these two hash value. Make sure it's identical to original. Okay. And then we need to calculate the checksum of the data to verify that data integrity. So this is normal for data file. Okay. Now for data analysis, there are several type of analysis of data, file system, network, malware, email, web history, and so on. Okay. If it is application, for example, it's what application for managing finance application. So we need to have that kind of analysis as well. Okay. So this is example of the analysis. File system, we need to identify type of file system used, directory structure, the existing file. Network analysis, we need to analyze the network activity performed by the device, including IP address, port, protocol, time, date, and so on. Okay, depending on the data that we receive. And this is interesting actually. For example, one of my colleague, Calvin, this is the guy. Okay, uh, this is the guy. He's currently doing his PhD. He is teaching at Swiss German University, and he's doing his PhD right now, and he's actually running the not botnet. What's it called? I forgot. Basically a sensor. So he running one of the biggest sensor network in Indonesia, is connected to the BSSN, the cyber security body in Indonesia as well. It's okay. Let me see if I can see the bot Honeyspot, Honeynet. So the Honeynet project, okay, this Honeynet project is actually run by Kalpit. So this is the guy behind this project right now. Okay. So they deploy, I don't know, maybe 100 of sensor all over Indonesia, and then he collect the data, and he's analyzing the data for his PhD right now. So he's actually doing those things. He's one of the forensic network expert in Indonesia actually, but his background is geophysics. He's not from IT actually. He's from geophysics at ITB. Okay. Okay. So that's Calvin. Just to give you some idea what kind of things we can do on these things. So he actually monitoring, but the sorry, one of the findings actually, most of the attack in Indonesia is actually from malware or Trojan and stuff like that. So many actually we are attacked by robots basically. The network is attacked by robots basically. That's the major finding. Of course, we know those things. Okay, then of course we need to do some malware analysis. We need to check the presence of virus, malware, or any malicious programs. Uh, Email analysis. I think I will do it today, hopefully. Uh, we will analyze the device, email content, attachment, metadata, and web history analysis. The tool that we can do to do the we can use to do the forensic. There are a lot of things. Most of the tools I wrote down here is proprietary, but because this is like my first run writing this note. But next I will put more open source tools here. Okay, of course, if it is more complex analysis, we need to do some coding, maybe using Python and so on. Okay, to do the analysis. But sometimes the analysis process can be done by like small tools in the operating system. Okay, for finding things. I normally use the tools in the operating system to find things and so on. Okay, now this is okay. Sorry, this is the examination procedure. So we still have the receipt of evidence, acquisition process, data analysis, and the documentation process. Okay. Of course, the documentation process will be described in the documentation, but we need to make sure we have log, screenshot, yeah, and chain of custody because we need to make sure uh, who held the evidence, when, where, and so on. Okay, so this is important. Hopefully, having chain of custody like this, then we can submit the evidence to the judge more solid. Okay, hopefully. The I've I have been dealing with several not judge court. I was like the I was the one who have to do this presentation. The problem in the Indonesian court, the judge, the law, they are not familiar with IT, so that's a major problem. And then all of us know that the evidence is soft copy, and we know soft copy. If it is hardware, it's easier. If it is soft copy, then we are in big trouble. We have to make sure it's not tampered, it's not modified. That's the most difficult part, actually. Many of the judge, when they see this is just an example. Many of the when we presenting to the court, many of the evidence, the soft copy evidence, we, for example, WhatsApp group chat. Okay, so we have WhatsApp group chat. What we normally do is screenshot the WhatsApp group chat and print and present this to the judge. The judge knows about WhatsApp. They knows that this is printed. The problem is how the judge know that this screenshot is not tampered, is not generated by by someone, not the original one. So many of the judges actually throw this kind of evidence to the garbage can. That's it, because they don't understand what this thing. So that's actually what happened. Okay. So when I talked to the judge, they said, okay, yes, this guy actually sending me a WhatsApp print out, and they print, but we don't know whether this is real or not. So I throw it in garbage can because the the one that create the evidence is not uh, strong enough. Uh, Not they have uh, they are not they don't have a very strong technical capacity, and then they also the chain of custody is not that strong. So normally this kind of evidence will be thrown into the garbage bin. Okay, so that's about examination procedure, and then the last one is findings. When we report about findings, there are several things can be part of findings. For example, suspicious files or important files. Uh, these files with usual extensions, file containing sensitive information, file that has been intentionally deleted. So that means we have to recover the file first. Okay, and then other findings is unusual user activities. When user access the system at unusual times, undocumented changes in access permission. Okay, repeated fail logins. Okay, evidence of data manipulation. For example, someone altering the log files, database modification, or delete of important data. and then digital traces linking to the perpetrator of the crime, IP address of committed crime, email account to communicate to those guy hardware used to carry out the attack if we can find one. Uh, this is actually interesting. Uh, okay, some of my friends actually managed to get hold of the hardware used by the terrorists, and then they managed to hardware is important. If we can find one, for example terrorists and so on, we then uh, we can recover many of interesting files from this hardware. uh, for example, in terrorist case, they have the file on how to take down the entire republic. So they have that kind of. This is not social. This is very technical documentation. For example, when we want to take down the whole republic, what kind of things they have to prepare. For example, they have to take down all the electricity first. They have to take down the and they have the plan to do those things. For example, they have the all the coordinate the of the high voltage uh, transmission line from the power company. They have all the coordinates. So they do a lot of homework actually to do those things. Okay, so this is interesting. We never know about this before, but when we see these things, oh okay, they are smart. They are not. So this kind of bad guys are not. They are smart guys, but bad. Okay, and then we need to data visualization tools to clarify complex finding, facts, graph, diagram, tables, to present the data visually, make it easier for the reader to understand. Okay, so this is important as well. Okay, now when analysis the findings, we need to think in our mind what is the significance of this finding or facts. Do these findings support contradict the initial hypothesis? Because normally when we do the forensic, we deal with a case, we have the hypothesis, why this case happened and so on. So when we find the findings, whether it is support or contradict the initial hypothesis, is there a relationship between one finding and another? What conclusion can be drawn for this finding? So we have this in our mind. Okay, relationship is interesting because it must be clearly explained. Researchers how should demonstrate how its finding facts support the or refutes support or not support the initial hypothesis. Okay, so this is example of the finding analysis. The discovery of unusual executable file on the system directory along with unusual activity from unknown IP address suggests an attempt to install malware on the system. This is hypothesis suggests. Okay. Additionally, digital trace linking this IP to server in another country reinforce the suspicion of cyber attack from abroad. So this one is so this suggests and suspicion is a little bit is not exact knowledge, knowledge basically. So this is suggestion. This is suspicion. The fact is this one. This is the fact. So we have fact. Uh, we have fact. This is fact. This is fact. And then we have some suggestion. Okay, so this is example of the finding. Basically, we have to be honest, objective, clarification, using the easy to understand language, clear structure. That's it. That's how to report the finding. Okay, but during the report, we need to have normally we have to have uh, Okay, we have to have the appendix, copy of represent digital evidence, activity logs. So all the details is in the appendix. It's not in the actual findings. So in the findings, it's only the summary of the findings. The detail we put it here. So not let the manager or the boss read the actual details. Let us present the summary only. Okay, that's it. Okay, that's about the report of the forensic. Now we have about 1 hour. Okay, let's do some email attack. So we will I will do some demonstration on email attack. Let me see. Okay, this one is the server. Uh, okay, okay. The server for demonstration is running on VirtualBox. If you want to have, you can actually build one yourself. It's not that difficult. If you want to have the file, the VirtualBox file, feel free to send me hard disk or something. Then you can get the OFA file of the this server. To make one, if you like to make one, you can read this. Okay. Kali Linux. Go to my what's that? Uh, my wiki page. The keyword is Kali Linux, and then here we have. Oh, this one. This is the one. Sorry, in Indonesian language. Uh, this part is how to install the server for our experiment. Okay, so I will do some experiment on email attack. Oops, sorry. Okay, okay. So this is our server. My IP address is if config 209. Okay, let me enter from this site because it's easier from here. Okay. Okay. Before I do things, let me explain about. Oh, let me see if there is any questions. No, no questions. Okay, let's continue. Okay. Okay. Here. I need to describe about the protocol email. So basically, all the internet use protocols to talk to each other, and all the protocol is uh, documented, very detailed. So for email, our protocol is this. Okay, basically we have three different protocols. One is SMTP, the second one is POP3, the third one is IMAP. SMTP used for send and receive email. POP3 for downloading email to local device. IMAP to synchronize email from server to our device. So this one is for download, this one to synchronize, this one to send receive. Okay, so we have three different protocols. For send receive, we normally use SMTP. If you like to read the actual standard, you can go to here SMTP RFC, or you so SMTP like this. RFC is short from request for comment. Actually, the actual web is RFC editor. So all the internet standard is open. It's stored in RFC editor, this website, RFC editor. Uh, for example, we want to learn how to the SMTP works. We just uh, search SMTP as keywords, enter. Now we have the so many standard on SMTP. The original one, the first standard is RFC 788. We can read in ASCII format. It's written by Jonathan B. Postel. He is a legend on the internet. He's internet legend. Written in 1981. Okay, I think many of you is not born yet. I was I was still a student, a bachelor student at that time, still very young, but he's already written a standard. You are welcome to read the standard. Basically, what I need to show is this one. So basically, this how the internet interact to each other. Basically, if it is a client sending comment to a server, it will be in text, something like this. For web, we have uh, get, we have what? Uh, there's for other comment for web, but this one for email. We have mail from, we have receipt to, we have data. That's from the client side. From the server side, from the server, they will likely to send numbers 205, 250, 250, 250, 32. So server will respond with number. User or human will talk to server in sentence. Okay, so that's the internet standards. Internet standards always like that. So user will talk, send text to server. Server will send numbers. Okay. Uh, the most famous number of the internet is 404, most likely. Okay, 4 is error. So if you have web and there is an error in the web, normally you will receive 404. So 4 is error. 2 is okay. 3 is submit the data. 5, if the server is missing, having problem and so on, is 5. So 5 we will receive 5 something if there is a problem with the server. If it is error, 4. If it is informational only, 1, something like that. Okay, so we need to understand the first number only, basically. 2, oh, okay, okay. So we will send something like this. Let me see this one. So this is more complete interaction. Client will send hello. Server will respond with two. We send mail from. Server will send to. Receive to. Two again. Data three. Go ahead. This is the mail content. And client send dot and server will send to, and then we can quit. This is simple mail transfer protocol. If it is post office protocol version 3, then the interaction something like this. Okay, user name okay, password okay, status we have two mail 500 bytes, retrieve number one, delete number one, quit, and so on. So this is for retrieving the email. If we use IMAP for synchronizing the email at the server and our server, then the interaction is something like this. Okay, let me show you the SMTP. Okay, I will do some. Okay, I will sniff the network. I will use Wireshark. So Wireshark is tool for sniffing the network. So I will sniff the network now. I will show you capture start. So it capturing the packet data. Let me see. Okay. 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 So this is the actual packet captured by the network. Okay, my interface, network interface. I will stop. Okay, stop. Okay, so it will not run. Basically, we can see on the left-hand side is the number of protocol layers of the network. We have five here. If we listen to a lecturer that explain about network architecture, normally they will say we have seven layer network protocol. In reality, it depends on who's programming the application. This one we have three, five. They have five. Okay, we have five, and we have physical layer. We have data link layer. This is physical layer. This is physical layer. We have data link layer here, and we have network layer here. We have transport layer here, and we have application layer here. We use user datagram protocol UDP for sending the package because this is video or this is multimedia. It's basically my sound, my audio sent to Zoom server. It's because it's multimedia. We are sending using UDP packet because no acknowledgement is necessary. We just send the data. If it's lost on the network, we don't care. That's UDP. Okay. If TCP, it will check for it will make sure that the data reach the destination. Okay. That's TCP. Now, I will start the capture process. Start again. Continue without saving. So it start capturing. Let me see. I will access the web. Oh, yeah. 0209 Squirrel Mail. So I have webmail running on my local server. No thanks. This is my username. This is my password. Okay. This is webmail. Uh, Sending running on my local server. I can delete this email. This is just example. So I will send email to the server and I will make sure the email reaches this website. Okay. Now to send the email, all I need to do is do the SMTP process. Sorry if this is quite fast for many of you because actually to understand uh, this kind of lecture you need to take the networking class first before we go to this lecture, but but it's not that difficult actually because many of you are using internet anyway, right? So network becoming part of you. So many of the jargon I will using is quite familiar actually. Okay, now I will send email, but I'm not sending using any application. I will send the email using my hand. Okay, so I'll connect to the server 192.168.40.209. Okay, so the SMTP port number is 25. How do you know it's 25? It's documented, well documented by the internet. You can read all the port number in this file. Surfaces, surfaces. Okay. Okay. So in the /etc/surfaces, it will document all the port number used by many surfaces. But we have to set the number in the actual server. We can always change the number. So, but this is the recommended number actually. Okay, so this is the number. TCP multiplex is 1, Echo 7, Discharge 9, FTP 21. FTP is File Transfer Protocol. And then what? SMTP 25, Telnet 23, Time 37, Who is 43, Trivial FTP 69, Finger, oh, Finger, long time. In the past, we have Finger. Now we don't have Finger. Let me see if it works. Let me see. It remind me in the old days. Finger. Oh, okay. Finger is no longer installed. Anyway, uh, okay. Oops. Let me review some of. See this web 80, POP3 110. What else? We have file sharing, window file sharing 137, 138, 139. This is net bias for window file sharing. This is NTP is network time protocol. SNMP is simple network management protocol. This is IMAP 2 protocol and so on. So we know the number of the port number of certain application. Okay. Now I need to connect to SMTP service. Okay, connect from which one? This one? Okay. Telnet. Let me restart the capture process. Restart. Otherwise, I have too many packets capture. Continue without saving. Okay, because this is very noisy. 129.1.0.209.25. Now I'm connected to the SMTP server. It it will tells you that the server actually postfix. It run on Ubuntu operating system. This is not good from security point of view. Okay, as a forensic guy, we can. This is normally used by ethical hacking. Ethical hacking is the activity. There is an ethical hacking class in my server as well. So I teach ethical hacking. In ethical hacking, this kind of information is very dangerous because the attacker will know the operating system of the server, and the attacker will know the application used for receiving SMTP message. Okay, back to this one. I need to send hello. Okay, so I will send hello. Hello. Okay, I will set this is a bad hacker.com. It's okay. It says okay. The server name is server.local. Okay. Now mail from. I have to tell the server that this is mail from, for example, Prabowo at President. So this is how people can create hoax. So creating a hoax, basically, we can send uh, mail message by uh, identity, not a real identity. So we are forging the identity. So I'm sending as Prabowo to re- receipt to. The name of my server is korban.com, and then I need to send data. Now I can actually send from Prabowo at Presiden I think the actual website without T, president without T. This is wrong. No. Okay, I will make it better. Okay. Two. For example, I'm sending this message to Minis at, for example, internal affair, internal affair dot go dot id. For example, okay. Of course, we need to have the actual domain actually, but this is the actual message. So actually, I'm sending to not the minister. I'm sending to Ono at Korban, but the text is going to minister. Subject: please come to the palace. Oh, not hello, dear minister. Please come to the palace uh, today at 1 o'clock, for example. We need to discuss. Of course, in reality, we need to have like more formal text to do this thing. This is only example. We need to discuss about our internal affair in Indonesia. Okay. Thank you. Sorry. It mustn't. Oh no, it must be Prabowo, but I cannot go back because there's no editor here. So I will send. Okay. So the mail is sent and quit. Okay. That's it. That's how we send message. Uh, Mind you, I'm sending the mail by hand. I'm not using any application. I'm sending the mail by hand. We can do the same thing to this mail. Okay. Now, let me see if I can sniff the email. Okay, I will capture stock. Okay, I capture too many packets. This is address solution protocol. Okay, I will filter then. IP address, I will filter to this one. Okay, now this one is buy. This is quit. So I get some of the packets. Let me click this one. So so I have simple mail transfer protocol. I'm sending quit, and then this one is buy. Okay, response buy, and the service closing transmission channel. Okay, now, so I managed to capture one of the packets. Okay, so this one. If I want to analyze all the activity, just click analyze, follow TCP stream. Now, I see the whole payload, the whole content that was interact between my computer and the actual server. So this is if we are able to capture the evidence in real time. This is what happened. So we need to do the uh, uh, sniffing, and then we capture these things. Uh, oh yeah, the sensor put by run by my friend Calpin actually capable to do partially of these things. So they can do capture some of the traffic, but they are not really interested to capture all the content. They are more interested to capture the header only. So this is the this they are more interested in capturing this part. They are not interested in capturing the content. But basically, what I'm showing you is this is how people what not stealing, uh, how people generate false information, hoax, is something like this. It's not that difficult. It's quite easy. So we can create any account, and then we need to do the we just send the message to this person. Now let me see how it looks like when, oh, see, there is one new message here, receive. Let me reload. So I receive this message. We can click here. See this, of course, because I cannot go back. So the signature still. Oh no, actually, I was thinking Pak Prabowo as the signature, but my mind and my hand is different. My hand used to be uh, type Ono, so I will Ono. No, it looks okay. Nothing wrong with this. Okay, but what happened? What happened if the minister actually go to the palace because of this email? Okay, in the palace, then people will be confused. There is no invitation for you, sir, to come to the palace to talk with the president and so on. So this will create some confusion in the Indonesian palace, of course. Okay, so when we attack, when we do things, it's not necessary hardcore. This is softcore basically. We just having fun, sending wrong message to to people and make them confused. Now, how can we, as a forensic researcher, we can see the full header here, and we can see uh, where the origin of the message. See this, receive from, this is a badhacker.com, from this IP address. So this is the forensic evidence that, oops, sorry, this is the forensic evidence telling you that the email is not coming directly from the palace. Okay, it's it's from, this is a badhacker.com. Okay, with IP address 9.192.168.0.3. Okay, this is the time, this is protocol use, and so on. So all the detail, also this is all the detail of the original delivered to, where the message is to Minister at Internal Affairs, but actually delivered to ono at korban.com. Okay, so we can see all of the detail on this header. So this is part of the forensic. The other, let me see, let me discuss some of the forensic activity. Uh, okay, this is how to attack. You can read this thing. Now, first, when, oh, okay, I did this one. Use Wireshark to capture the network traffic to the webmail, and I capture the port 25 SMTP activity. So this is done, but I have to collect the evidence for report actually. So all you have to do, just capture screen or uh, select. Oh, sorry, where is it? Where is it? This one? Uh, where is the? Okay, okay. We can capture this one, select this one, and put it in the appendix in the report. Okay, so we need to collect all this evidence. Okay, make sure if you do the actual work, we need to copy paste in our report. Okay, so this is the Wireshark evidence. This is the one. Let me see the log. Okay, there is access log, error log, mail log, and so on in Linux server. Okay, the log is, let me see server. Okay, so let me make it bigger. Clear. 209. Yes. So now I enter the server. Just brief overview about the server. I will I will set myself as administrator. So I type sudo su. Su is super user. I have to type my password. Uh, all the configuration file in this directory /etc is all the configuration files. Okay, log is normally in dot /var/log. It's log. So log is here. There are several log files here. For example, you have authentication log. You have what? Apache is for the web. Because I install the FTP server, I have FTPD log as well. And this one is the mail log we are interested in. Let me see mail.log. Okay. So this uh okay 30 October. Okay. The time here is UTC. No, no, yeah, UTC plus zero. We are in Indonesian time, so our time is +7. So we are 19:33. It happened. I read the email here, uh, 28 plus 7. So basically, this is London time. Okay. Now, uh, we have here when we send the message, uh, the server postfix receive message from IP 192.168.0.3 at this time. See, the connection rate is 1 per 60 seconds from this port. Okay, so we can see what happened here. It's from here is when the interaction is done. Here we can see. Let me see if I can see. Okay, the postfix here. So there is a mail from Prabowo at presidenri.go.id and then received by Ono at korban.com, delivered to mailbox, and then one hello, one mail, one receipt, one data, one quit, 5 comment in total, finish. Okay. Now I use Dovecot to read mail. Oh yeah, so this one is I use Dovecot. Dovecot is connected to the Dovecot is POP3 and IMAP server application. I use IMAP for this webmail here, this webmail. So this one actually use IMAP to talk to the server. Okay, so all tracked down by the lock. Then we need to secure. We need to copy paste. We need to take note all this note log to our report. Okay, because this is very important. Okay, now so this is how the log looks like. Okay, now uh, email header analysis. Here is the email header analysis. That's the my actual mail. This is my dummy mail. Let me see the header. This is header. Okay, this analysis. We need to see. Let me move it here. Okay, identify fake sender address. Look for sender address that doesn't match the sender identity. Uh, this one. This is fake, but there is no way for the application to know whether this is fake president or not. Okay, to to be able to have uh, ability to identify whether it's fake or not, we need to install uh, uh, public key, private key, that kind of stuff. Okay, let me show you a little bit here.
はあ、ちょっと待て。
Let me see. Okay, I go here. This is here. Yesterday, I will remove this one. Delete key. So we need to generate to have a key to authenticate whether this is real or no or real Prabowo. Generate the key is not that difficult. Just add keys, and then I can create new pair keys. Because this is only for experiment, I will expire the keys in 3 days only. The keys are quite long, 3072 bit keys, very difficult to hack. Then confirm. Then this kind of technology is used to authenticate actually. Where is it? Here. To identify fake address, it can only be done if both sides agree to use public key, private key, digital signature, and stuff like that. If it is not used, then we are having difficulty to identify whether it's fake address or not. Okay, but because time is limited, I'm not sure if I can describe in more detail. But if there is time, I will try. But if not, I'm in trouble. And then, so this is identification. At this point, we are stuck with. Sorry, we are stuck with this only. Okay, we are stuck with this. We can only guess whether this is a real address or fake address. So we are guessing only. In real life, we need more than this to identify whether this is fake Prabowo or real Prabowo. We need more than this. Same thing with WhatsApp. Same thing with Telegram and so on. We need to make sure whether this is real guy named Ono or Prabowo who send the message on WhatsApp and so on. Okay. To be honest, by email, it's much more easier for us to identify if we agree to use the this Thunderbird. This is not Thunderbird exclusive plugin. This kind of plugin is you can find the keyword is this Open PGP. You can install Open PGP on other machine. It will talk to each other. So the Open PGP is open source, open standard. We can use in Thunderbird. We can use in any application actually. I personally like to use Thunderbird because it's much easier, just like this. Okay, so I have a new key, then we can exchange key using Thunderbird. Okay, okay. Now receive key already explained. Uh, we need to read the header to trace email journey, identify suspicious relay server, and so on. Okay. Then, if it's needed, we can actually analyze the email content. Uh, Sign for phishing, suspicious link, misuse attachment, request for information. Actually, in our particular case, is actually no suspicious link, no miscellaneous attachment, no request for personal information, but it's fraud. Okay. Now, in log analysis, this is not happen actually. We need to. This is, for example, we want to see unusual login activity. There is no unusual login activity, no failed access attempt, no unknown comment. So there is nothing here. We need to identify the attacker IP address. Yes, we can see here the IP address. Oh, sorry. Where is it? Here. The IP address of the attacker is this one. Okay. Yes, we found one. And then analyze the timing of the event. It's from the log. We can see when the email received and so on. Okay. So we can see the analyze from network packet capture analysis. We can see we done the filtering, and we can see the email using SMTP. Uh, this is look for suspicious packet. The packet is nothing suspicious, but the problem is the suspicious is in where is the log here? Okay, the suspicious is this one. Yeah, from and also in the content we can see something suspicious here. Because of that, this is also suspicious. Okay, so we need to take note of these things, and we can reconstruct the entire conversation between client and server. The reconstruction is, oops, sorry, where is the reconstruction? Oops, sorry, this one. Oops, sorry. Yes, this one. This is the reconstruction. Can I make it bigger? No. Oh, sorry. Okay. So this is the reconstruction of oops, sorry, reconstruction of the connection to view the entire conversation between client and server. So this is the reconstruction. Okay. So the mitigation of this kind of attack, we need to make sure to install GNU PG. In my case, I install Open GPG. I need to change this one. Login. Okay. Okay. GNU PG or Open GPG. Okay. Install GNU PG slash Open GPG. Okay. We need to generate public key, private key. Okay. Okay. I did the generation. See this one. So yes, I did generate the public key, private key. All we need to do just add key, and then we generate the key. Okay. Now, configure the email client to automatically use GPG for encryption, or Open GPG, GNU PG, or Open GPG. Okay. Then we need to teach users how to verify digital signature on receive email to ensure message authentication. Okay, now I need to tell you how to verify the digital signature on receive email to ensure the message authentication. Let me do it here. Okay, this is my email. This is uh, the daughter of the security guy at my house. Okay, now to activate the encryption feature in Thunderbird, it has this option encrypt, and it has the option this option open PGP. So it has two, encrypt and open PGP. If I encrypt this this will be activated, and also the subject will be encrypted, and then it will digitally sign. Okay. Uh, we need to understand first how the public key, private key works actually. So this is part of the cybersecurity course normally. So in cybersecurity course, I normally teach how the public key, private key works. There is another key called symmetric key. Okay. Basically, if he have text, we can encrypt using symmetric key. The text will be sent, including the symmetric key has to be sent. Otherwise, the other side cannot decrypt the text. Okay, but I will skip that uh, explanation. I will jump directly on how to use the encryption, public key, private key, and so on. So basically, I already have the public key, private key. Uh, Let me see. So here, when I in the end-to-end encryption module, when I generate, when I add keys, it actually generate the private and public key. The private key is in the Thunderbird, while public key we can publish. We can publish when we click publish, it will be published. Okay. The key sent to keyopenpgp.org, so it is published. Okay, but it's expired in 3 days from now. Okay. Of course, we can manage the key from others using OpenPGP Key Manager, and then we can manage key from others. Here, there is only one key stored in the OpenPGP Key Manager. Okay, so we have the key. Now, how can we use these things? First, normally, I will send my public key to my destination, the one that we will do the correspondence. Okay. So, for example, I will talk to another Ono. So I talk to myself. Before we do the interaction, we need to send this guy public key. So this is normally I will send Ono public key. How can we send the public key? Just attach my open PGP public key, attach. That's it. Okay. And then send. See, there is one attachment. See this here. Ono public key is received. Here, this is the attachment. Let me see how it look like. I will. Oops. Okay. It it sent directly to the key manager. Uh, I like to show how it look like. Let me see. Oh, I can do. So it will sort in the key manager, and then so I have the Ono public key. So the one who has the public key will be able to send encrypted message to this certain person that we have the public key, and then only this particular person can read the message. Others will not be able to read the message. Only this particular person will be able to read the message because we encrypt the message using our public key. Basically, that's how it works. Now, uh, having said that, uh, this one is not encrypted. We can view the source. Okay, so this is the what's that? The header, the email header that I sent. You can see this IP address is uh, translate into this public IP and then received by smtp out indo.net.id, and then received again by pop01indo.net.id, and then it was scanned by antivirus. This is antivirus Debian. So we know the pop01 internet ID use Debian machine. It has its own antivirus, and then antivirus sent again to internet, and then that's it. Then I download the key. This one has nothing to do. So this is actually the public key. This is the actual public key. So this is the public key block. Okay. Oops. Sorry. Okay. This is public key. This is public key. This is my key. Public key. This big. It normally will start with begin, PGP, public key block, and end PGP, public key block. This is automatically generated by the machine that use OpenPGP. If we save using OpenPG to folder downloads, it will save as OpenPGP 0x9 FEE and so on dot ASC. ASC is a text format, but because of this keyword and keyword, this ASCII format and OpenPGP, the Thunderbird will read the format and uh, load into the key manager. That's it. Okay. So we have the public key. Now, having the public key, we can the normal message will look like something like this. This is uh, plain text message. So this is the mitigation. Yeah. So this is nothing to do about forensic. This is about the mitigation. How we mitigate. I will send text message. This is the actual text message looks like. So when we read message like this, we can view source. Okay, this is how the text message look like. So this we can read because it's plain text, no encryption. We can read. Okay, this is a code of the mail for auto encryption and so on. But this is not used. Only this one. Okay, so we can read the message. Okay, because we are not encrypt the message. Now, if we want to encrypt the message, we can do something like this. I will send to Ono uh, encrypted message. It's sorry, encrypted message. Okay, so from Ono to Ono, the message will be encrypted, and then I can click this one, encrypt. So the message will get encrypted. I can check using this one, OpenPGP. You can see encrypt is uh, we is it note that it will encrypted, subject will be encrypted, and it will digitally sign. There is a digital signature in the message. Digital signature is not my signature, my normal signature scan. It's not my signature in. It's digital signature is different. Okay, now I send the message. Okay, look at this. This is we cannot read the subject anymore because it's encrypted. The whole message is encrypted. If we click, it will check whether the one who read is actually Ono. If the one who read the message is not Ono, it will not allow us to read because I am the one who send and receive. If I click, I can read. I will click. Now it show encrypted message. It showed the text is encrypted message, but here I can see the OpenPGP. The key is green. That means it's okay. Show security, message security is okay. If I click this one, it will show that it has a good digital signature and the message encrypted is also okay. This message was encrypted before it was sent to you. Encryption ensures the message can only be read by the recipients it was intended for. This is important. Only the one that intended for can read the message. If I click the signer, then I can see who signed the message. Okay. If I click the decryption key, I can see also who actually encrypt the text. Okay. So this is there is two things: signature, the message. It can see who signed the message. We can see who encrypt the message. There is two jobs here. Okay. Now, how it look like? It will look like something like this. Okay. All of this becoming an evidence actually in the forensic world. Okay. See this? We cannot see the actual text anymore, but we can see begin PGP message. This is the actual message, and this is end of PGP message. Okay, so we can see the whole message. It's encrypted. We cannot read anymore. Okay, now let me send normally in what's that in the office nowadays in the government in many of the private sector company and so on we have digital sign digital signature but normally the programmer or the actual server or the actual application will not show you the how the digital signature looks like. So this is a common method. So the method for encryption of the email is the same as the method to encrypt the document or to do digital signing of the document is the same, no difference. Okay, let me show you how it looks like. I will send a message, but digitally signed message is not encrypted. So I will digitally sign only. Uh, the message will not be encrypted. That means this happen if we digital sign a document in the office. The message is the text is not encrypted, but we add digital sign to the message. Okay, how it look like? We can do something like this. We will not encrypt the message. We will not encrypt the subject, but we only do digital sign only. So we just click this one, digitally sign. Okay, see, only digital sign, and we will send the message uh, only digitally sign. So digitally sign only, no encryption to the message, to the text, to the content. So I will send these things. Okay, see, digitally sign message is not encrypted. If I click this one, we can read the message, but this one, we have this one, open PGP. Let me click this one. The normal one, plain text, there is no open PGP in plain text. In this one, we have open PGP. So that's the difference. Okay. Okay. And then if I click this one, it show good digital signature. So digital signature actually will tell you two things: who's signing the message and whether the text is modified or not. If it is good, that means the signer, we can check the signer, and the signer is okay. I can treat this key as personal key, it's okay also. And also the text is not modified. That means the whole system managed to make sure the data integrity. Okay, so the data is not modified, data is preserved as it is. The data that we receive exactly the same as the data was sent. The text received and text sent are the same. So this is what it means. So uh, this is normally we normally use this for ethical hacking. Okay, but in forensic, of course, we need to understand that there is technology something like this, and we use this as recommendation for mitigation if there is any problem in the email if it is forged. It's costly if somebody email if we are not using this kind of things and we interact and it happens with the client of Bank Central Asia actually, and it cost them hundred of million rupiah because they are not implementing system like this. Okay, so they are they receive a social engineering email and they transfer hundred of million rupiah to a company in China because they are order things and a hacker pretend to be that particular company and telling the company that the goods they are ordering has been sent by they have been shipped the order and the hacker asked the company to transfer the fund and the company the finance of this particular company is not that technologically savvy, so they just send hundred of million rupiah to this hacker account and the money is gone. So that's what happened. So this is real. We need to collect all the evidence. But unfortunately, in this particular case, because this is happened in two different countries, it's very difficult to take down the hacker. Okay, let me show you the how the source look like. Okay, this is the source. So same, we have the headers here. Okay, now we have the public key here and we have the digital signature. Actually, the this particular digital signature is the same if we do the digital signature in document and so on. The actual digital signature is look like this. But in many documents in the application, normally they show you as a QR code or URL and so on. Actually, the actual digital signature is like this because the technology used for signing the document and this email same signing the document do the secure any secure transaction is same technology actually. Okay, so this is the guy digital signature and it also send the public key block. Now the text this is actually the text. Okay, it's look encrypted, but it's not encrypted. So basically, we just do encode and decoding. It's not encrypt decrypt. It's different. If it is encrypt, then we randomize the text basically. Normally, if it is encrypted, normally begin PHP and end PHP that's encrypted. If it is not encrypted, we have this text like this, but different encoding. The original text is encoded in ASCII. This one is encoded in base 64. So that means we have to uh, transform from base 64 to ASCII again. All we need to do just take this one, copy the base 64 text. Now we have to find how to uh, decode on the internet. Base 64 decode. Decode. Okay. There is a web base64decode.org. Uh, okay, decode for base64. Paste the text here. Okay, and then decode. Let me see here, so we can reread the text here. So it's not encrypted. It's decode. Little bit safe, but it's not safe. If the hacker smart enough, the hacker know this keyword, content transfer decoding. So all we need to do, just read this one. Okay, the text is decoded in base 64. Then all we need to do is look for decoding tools on the internet, on the web, and we can decode the text actually. If it is, but this kind of text, this signature, make sure if someone actually changed the text, it will detect. So it the actual text is not encrypted, but it's protected by the digital signature. So the digital signature will tell you if the text is modified. The digital signature will tell you if the text is not sent by Ono. Okay, so this is for protection. But the actual text is open to people to read. So that's why if we have like PDF file and we want to have digital signature, we normally put the digital signature in the PDF file, but the whole PDF file is readable by human. So human can still read the PDF file, but it has digital signature. So digital signature basically just add a layer of protection if someone changed or modified the actual text. Okay, so that's it. Okay, let me see if there is any questions. Any questions? Okay.
I have questions, sir.
Oh, okay. Sure.
Yeah. Thank you, Sarono. Question number one is regarding the quiz. Would you share the link, Sarono, and also how many chance we have to do the quiz?
Oh, okay. The link is the open course. This one. Yeah, let me repost again here on this one. So all you need to do is to enroll this class. This is the IT forensic class. If you already enroll in opencourse.itts, use the same username password. Re-enroll to this class 105 class. Okay. So the for that enrollment key is ITTS PU 2023. So there's the enrollment key. So make sure you enroll. Now, how many times? As many times as you like. No limit. And I will, the system will take the highest score. So for example, your score now is 70. The second attempt, the score of second attempt is 50. It will take the 70. It will not take the 50. So you can do the exam as many times as you like. The system will take the highest score. Any more questions?
Yes,
And
question
oh,
number.
anyone recording the lecture? Okay, I am recording the lecture. I hope it works. If not, we are in trouble. Okay, another question? Yes.
Yes, I have the other question. Question number two is you describe regarding the forensic report, and but
Uh,
I forget which part you mentioned about this. Avoid excessive technical jargons. Can
okay.
you please more elaborate about this? Avoid excessive
Technical
technical
jargon.
jargon. Yes,
Oh,
excessive
okay.
technical jargon.
Okay, for example, the easiest way is the the easiest way is to show you in ChatGPT, for example, or Gemini. Let me use Gemini maybe. I don't know. Uh, okay, okay. right? Forensic report with heavy technique report on what? Email, email attack, email attack with heavy technical jargon. Okay, that's the easiest part. Uh, like these things. This is quite heavy. Nih. It sells IP address. This is the IP address. The normal management person, they don't understand what it means. Uh, Reverse DNS lookup, IP address. This kind of thing is very technical. Okay. Uh, Keylogger, backdoor, is technical, very technical. Okay, let me rewrite the. So this is the technique, the example of technical report uh, with heavy technical jargon. If I use and remove any technical jargon. Okay, okay. Let me see if it gives you a much better. See? Oh, still here. Well, this is quite technical actually. This one. Where is it? The rest is more subtle, not much technical. That's it. Only one. This one. The rest is not as technical as the previous one. So this is one example. Okay. Any more questions? I hope that's answered.
Okay. So the context is how to prepare forensic report
uh
uh, for a for a court.
Okay.
You mean?
Oh, basically the judge, uh, they are more interested in the event or chronology of the event, how the event, the timeline of the event, and then so we need to make sure that we have a correct timeline. So, for example, we find at this date, this time, this person try to attempt to do several attempts to log in to enter the system but fail. So we use that kind of things, and then all the evidence, the technical evidence, we put the in the appendix. But the what's that? The description is as simple as that. Okay, so so that's what the court looking for actually. Uh, that's it. No, if we are having difficulties, normally I will today I will use Gemini or ChatGPT to translate the technicalities into something more readable for normal human. As simple as that,
Okay.
actually.
Okay. Thank you.
Otherwise, it's difficult for many of us actually. Any
Okay.
more questions? Okay, time
If the lecture
is
is recorded, if the
what's that?
lecture is recorded, if the lecture is recorded, how can we reach it?
Read the record. Okay, it's recorded on my computer. I will stop recording first. I will upload to YouTube. Let me see if I. So this is the recording.
Yeah,
Let
and
me
once
see.
uploaded, just give us
Okay.
the link if you can.
So the recording is here right now in my folder. I will upload to YouTube. Here. This is my channel. Okay. Let me show you. This is my channel. Oh, sorry. This is not my channel. My channel is Ono Center. Make sure you go to this Ono Center channel. Okay.
Hmm.
And then, oops.
Is there a
Okay.
playlist for the course itself?
Uh, so it's not in President University channel. It's on my channel because I cannot access the university channel. I will put in my channel, Ono Center channel, and then look in the video. Normally, I put it here.
Yeah, I understand, but
Yeah.
will it be in a random way
Huh?
or well arranged in a playlist specific just to IT forensics subject, and each
Oh,
subsequent record will be there?
oh, okay, okay,
Yeah.
okay. Yeah, good suggestion. So I will create a special
Special
playlist.
playlist,
Okay,
just specific for
okay,
this subject. We
okay.
can catch later.
Oh, okay, okay,
More later. Yeah,
okay,
thank you so much.
okay, 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 okay. So I will create a special playlist on IT forensic. But to be honest, uh, I'm having difficulty with YouTube because normally YouTube will delete my file. For example, this class, I actually do demonstration how to attack, and YouTube is doesn't like someone uploading that kind of video. So I will try to upload, but uh, if I think YouTube will having problem, I will put a not in public, but then I will send you guys email the actual URL, but it's not a public URL because I'm having difficulty with YouTube because it normally will take down my video.
No problem, no problem at all.
Okay, okay then. Thank you very much. See you next week.
Thank you,
Thank
Okay.
you.
sir.
Okay. Bye bye.